Hi, this is Aaron from Sibling Rivalry, and today we're going to be doing part 4 of our mechanical keyboard build. If you've been following along, you should already have your circuit boards, and I'm going to be showing you how to go from this to this.
A machine that can make copies of almost anything.
But today is the assembly of our DIY 3D printed mechanical keypad. And you can actually see over here, I've already done this assembly, made sure everything worked and tested it. And we'll be showing you some assembly tips and whatnot, as well as showing the parts. And then I'll just kind of use this as like a demonstration rather than kind of wasting your time and watching me solder 9 switches in rapid succession. So yeah, let's get started here. So to start out, what you're going to need is a version of your 3D printed case. So that's the plate part as well as the base. What I've actually done is I've gone in and modified the files for this. You can see here that I've done a little indentation, and that is to help the switch stay in place, which is great. It kind of makes sure that everything stays in its spot, doesn't wiggle around, doesn't pop out. You don't have to worry about your board coming loose or your switches coming loose. I've also gone and resized a few things just for aesthetic purposes, and I've added a higher diameter section here for heat set inserts. But what I'm actually going to be doing, because I had some problems with the heat set inserts I bought, is just threading directly into plastic. So I've actually gone and designed a different base that's got a slight, I don't want to say tenting, but it's got a angle to it. So that allows you to kind of have the keyboard sit at a bit of an angle. So it's nice for ergonomics, and if you're using this as like a Stream Deck alternative, it'll allow you to see what's on the keys a little better. Aside from the case, you're going to need your PCB, which we ordered in the last video, if I'm not mistaken. You're going to need 9 MX or Alps compatible switches. The design that I've done for the case is based on MX switches, but you can easily follow along and just switch in the keyboard plate builder to Alps style or Matthias style switches. There's no real difference there. You're going to need a Arduino Pro Micro. I've grabbed this one off of Amazon, but you can get them pretty much anywhere. Great thing about the 9 keypad is it's compatible with all the different sizes of Pro Micro clones. The normal size, max size, and the half size. And the only other thing you're going to need, and this technically is a optional part, is the reset switch. I personally wouldn't regard this as optional, but you can technically flash the firmware without this switch. I think this is just a 5mm tact switch. I know it's a single pole, single throw, as you can probably see on the camera there. You could always just use a piece of wire or a jumper or something to replace this, because if you're only installing firmware once, you don't really need a switch. But in my case, I installed the switch on this guy so that if I want to change the firmware or change the key layout and different things, add different features down the road, we've got that option, which I'm planning on doing a few more projects in the future based off of this. This is essentially going to be the baseboard of a whole bunch of different mechanical keyboard videos, ideally. So I'll have a link in the description for where you can get all these parts. You can buy these switches in a variety of different places. I bought some cheap clones. They're New Giant, so they're not even like an actual proper clone brand. They're a clone of a clone. You can buy them on NovelKeys, KBDfans or Keyboard Fans. Order them all over the place. Even Amazon, I think you can get the NovelKeys special switches with a bit of a markup, but you'd avoid customs and shipping fees and stuff like that. So it's an option. So let's get started here. The tools that I've got my trusty little USB powered soldering iron. It's not the greatest thing in the world, but it works really well. I'll have a link down again for this. I've also got some 60/40 solder. You can use whatever type of solder you'd prefer. I like 60/40. It just kind of flows really nice and works for me. And it works with pretty much any iron that I've used, like low temperature ones like this guy, which is, yeah. I tried using like silver core or like tin core, like ROHS compliant solder with this guy, and it's been a little, it's struggled with it a bit, to say the least. Now with this iron, I'm just going to step back to this for a second. I am using a battery pack. So just a little USB rechargeable battery pack here. I think I got this at Walmart, but you could get one online. We'll have a link for an Anker brand one, because Anker is just honestly like the best brand that I've experienced with these battery packs. I'm using the battery pack partly for portability and also partly because the isolation on the ground on this iron is not great. It's not really ESD safe. You're going to want to essentially power it from an isolated source. So unless you're just doing like basic soldering with no microcontrollers, no like fussy electronics. If you're just soldering like discrete components, I would say, no integrated circuits, then you should be fine. But check out Big Clive's video on these irons. We might have a link for that as well. He does a good review of them. They go by a bunch of different brands. They're all just China export, and they work. They actually, surprisingly, they work. So, and it's got a little activity sensor thing in here. I think it's like a tilt sensor as well as a touch sensor on that little silver nub there. I've also just grabbed a ramekin and a Scotch-Brite pad or like sponge that I dampened just to kind of clean the iron tip as I'm going so that I don't get all nasty. Ideally you want to use like brass wool, but if you're in dire straits you can always use this. My brass wool is MIA right now. So got the iron heating up here, and we're going to start by soldering on the switch. The power, or not the power switch, the reset switch. So maybe don't do what I'm doing and hold the iron in your hand while you're doing this, but I'm not too worried. So these guys come in tape. You can get them from a variety of sources. DigiKey, I think, is where I bought them. Yeah, if I look at the label, it says I bought them from DigiKey. You can get them from the Easy EDA company, like partner company that does components, the one that works with JLC PCB, where we ordered the circuit boards from. They've got a component store that works with them. And I'm actually going to show you guys a little trick with these hot air solder leveling pads that I mentioned in the last video. So what you can do, and I'm just going to get a little close here, it's not going to tack it too well, but as long as the iron is hot, you can actually tack these in place occasionally with the solder that's already on these pads. And you can see right there, it's tacked in place just well enough. Now, this board is a mirror image. You can solder it either way. The way that you do need to attach these is the, what's it called? Like the same orientation you're seeing here. So you want to have the Pro Micro facing up, like component side up. You could flip it, but then I believe your matrix for the switches will flip as a result. But yeah, so just go in the orientation that I've got here. So I've tacked this, and now that I've tacked it, that corner is tacked, I'm going to go in and do this corner, and we just need a little tiny bit of solder, just enough to get everything to stick. So now I'm going to turn this around. And this isn't like the work surface that I'm on here isn't like a specialty surface or anything. I think I literally bought this at the dollar store. It's a Oh, my iron just went to sleep. It's a cutting pad. It's mildly temperature resistant. It's good enough for my purposes. It's more just to avoid burning the table, because this is our kitchen table here. Okay, so now that these three are all tacked in place, realistically, once any of them are actually fully soldered in place, you can go back and replace the, or supplement the tack here that you made. If you can't tack it, you can also just hold it in place and just solder, or just set it in place and solder, or you can even melt the solder onto the pad directly, like I'll show you with this guy, just as a demonstration. So you can just do that, and then once you've got that pool of solder on there, you just take the switch and from that, you just take the switch out. Hopefully don't drop it on anything other than your hand. Set the switch on the board and just make sure you've got the right orientation here. It's pretty straightforward. It's literally just the way that it shows. And you just kind of push that in and solder it. And there we go. So once more, for anyone who wasn't watching, we'll just go in now that that's tacked this way. Solder. Oh, just trying to get the solder in a tight space. I personally like to hold the solder with my hands. I know some people have like solder pens, or they'll use solder paste even instead of solder itself. I just like the control that having the solder in my hands gives me, so I can kind of move the solder around and the iron at the same time to kind of work the joint and make sure that it's nice and consistent. I know everybody's got their own preferences. It's kind of just, you change from experience. Like as you work with this stuff, you just kind of come up with your own personal preference on how to do this. It's like any tool, really. So we've got those done. Now, what we're gonna do is the fun part. I am going to take the Pro Micro out of the package. We're actually not going to be soldering the Pro Micro in. That's going to be one of the last things that we do. But what we're going to do is work on these headers. So with these headers, you might have noticed on this guy, I've got the pins all flush and nice there. So the way that I did that is what I'm going to show you right now. So we're going to make a header sandwich. Doesn't really matter which set of holes here that you align this in. You just want to set the headers into the holes and then take the other one, the other PCB here, and just kind of align it. Excuse me. And don't do what I just did. Make sure that you actually align it into the appropriate holes. It might take a little bit of fiddling to get this to work perfectly, but once you do, you'll see what I'm getting at here. So rather than trimming these pins to be flush, which if you might notice that depending on the thickness of your Pro Micro board, the circuit board should be roughly the same thickness. So we know that we want that amount of pin left over, essentially the thickness of this board. So if I'm not making sense, you'll probably see what I'm talking about in just a second. We've got the sandwich. I'm setting it short side down, and we're just gonna push down with the top PCB, and that is going to force the pins upwards and force the plastic part down, like the plastic spacer there. So now you can see, let's see if we can get this nice up close. Yeah, you can see that the pins are almost completely flush. If you do this on a hard surface, you'll actually notice probably a bit more success, but you could do this on pretty much any surface as long as you're not too worried about bending things or denting them. You could do this manually with each one. I'm actually just going in with the flat end of my edge cutters here and just pressing down each one individually just to get it nice and uniform. You can just kind of run your finger along the length of the header and feel to see if there's anything that sticks out. So like if I run my finger along this one, I can feel that there's a few pins that are sticking out just a little bit. And I just go in with this guy, press them down, hold the sandwich in place. And this kind of reduces the amount of cutting that we have to do, which is personally my least favorite part with these pins, because as you'll probably see in a second, cutting these pins, oh, there's a guy still hanging out there. There we go. Cutting them, they tend to fly everywhere. So if you try this just like straight like this, you'll notice that the pin will just shoot off. I'm just putting my finger over top of it just to kind of catch it, but if you don't watch where these pins go or don't hold on to them as you're cutting them, they will fly literally everywhere, and you'll have little tiny shards of metal. And if you're unlucky like me, you'll end up with one stuck in your foot, or your sister's foot, or your dog's foot, and that's just not fun. So I'm just going in and clipping these, and I'm just holding the pins. If you don't have two circuit boards, you could theoretically do this part by inserting the short end into a breadboard, like a mini breadboard or something, and then setting it with the PCB on top and trimming it like this. But yeah, I'm just going to do it this way because I've got using what I've got here. And if you followed along exactly the way that I did it, you'll have the exact amount of parts that I have, or that I'm showing you at least. Okay, let's see. And you just want to make sure that you press the flush cutters flush against the part. Press as closely as you can to the circuit board without damaging the circuit board. And then snap. Okay, there we go. And that's pretty nice on that side. You can always go in and touch these up afterwards. They might sting a little bit even while you're holding them because there's a lot of force coming off of these, because as you're cutting into the pin, if you think about it, it's compressing the metal, and then the metal's gonna snap and shoot upwards. So it's gonna have a lot of little forces at play and little tiny stabby missiles. So let's do this. Oh, and I just realized I soldered this to the wrong PCB. Good thing we've got an extra switch. Okay. Guess we're using the last of these switches. I'll have to order some more, because a lot of designs use these switches. So someone probably was screaming at me the whole time that, oh, Aaron, you're soldering it wrong. You didn't use the right circuit board. Yeah, my bad. Little out of it today. It's a weekend. I'm a little tired. It's been a long week. All right. So now we're just going to go in and solder these guys. So as you can see from what I'm doing here, you can solder this in at really any point in the assembly. As long as the switch is accessible, you can solder it. The great thing about surface mount stuff is you only need access to that surface to solder it. Now let's clean that tip. Yeah, that does a good enough job. There we go. All right, so back to where we were, rather than going back and recovering our ground. So we've got the switch in there, we've got the headers. Now you probably want to solder this on there, but you actually don't, and I'll tell you why. How are you going to solder these switches in if this is in your way? What? So Yeah, and you always want to make sure you get the headers in before you solder in the switches as well, because if you have the switches in there, it prevents you from accessing these pins as easily, especially if you have, for say, this in there, and you got this soldered on, even if it's soldered the other way, how are you gonna solder any of that stuff? It's just not doable, not without mangling your case, ripping it apart, and then not being able to use it. So that's why you always think about your order of operations before you start something. So Pro Micro is actually going to be the last thing that we solder in. What we want to do now is put your switches into your case. Ideally, you want to do the middle ones, the ones that are going to be under the Pro Micro there, and you're going to solder them in. So I'm actually going to skip over that just because I don't have a bunch of switches to sacrifice to do this. But from there, as you can see here, you just solder in the switches. Then you solder on the Pro Micro the same as we soldered this. So you just apply just a little bit of solder, get everything nice and even. I just see a little thing here I'm going to clean up because it's bugging me. Okay. And then you should have this assembled. Only other thing you have left to do is attach the base of the case. So I'll have the designs for these cases linked down below if you want them. I might actually throw them up on my Etsy store if you want one printed. And yeah, that about covers it for our soldering. So if you've been following along, your board should look something like this, or some stage along the process. Ideally, not a empty PCB. If you have any questions, if you're stuck anywhere, please feel free to let me know. I'm more than happy to help. Let us know in the comments down below if you have any questions, comments, concerns, if there's anything we can do to help you. Like I mentioned, we'll have the case up on the Etsy store. We might include some of these circuit boards because what am I going to do with 5 macro pads? So we'll include some parts maybe. We might do a giveaway, but yeah, let us know what you think in the comments down below. If you like the video, please give us a thumbs up. We really appreciate it. If you're not subscribed, feel free to subscribe. We're going to have more content like this in the future, as well as some different content. Just check out our channel for a better idea of what sort of stuff we do. And yeah, thanks for watching. Hope you have a great day, and stay tuned for the final part in the main build, where we're going to install the firmware and get this working. Bye for now.